Welcome to this video about Cross-Site Request Forgery attack, or also called CSRF attack or XSRF attack. In this video, we will explore how an attack can be executed on a system without protection and how implementing CSRF protection can help keep your systems secure. We have two scenarios represented as two sequence diagrams. In them, we have four key participants: our actor, an innocent user who could be harmed by a malicious attacker; the user agent, which is the browser application used to navigate the internet. We have an honest server, which is hosting the legitimate application the user interacts with. Lastly, we have an attacker server, which is hosting a malicious HTML website with embedded JavaScript. This website doesn't display any content to the user but contains a hidden form that targets an endpoint on the honest server to perform malicious actions on behalf of the authenticated user. The form is submitted automatically via JavaScript as soon as the page loads, requiring no user interaction. Just visiting the page is enough. Let's start with a flow without protection first. First off, an innocent user logs into an honest website via their user agent, their browser. The user agent sends a request to the honest server to access the logged-in website. The honest server authenticates the user and creates a session token. The session token is stored on the honest server and sent back to the user agent along the logged website. The logged website is sent to the user agent and it is rendered. The user agent stores the session token in the browser cookies, allowing the user to stay authenticated for subsequent requests. In a regular situation, the user may need to request a sensitive form to be displayed on the screen. This form is sent back from the server and then the user fills it and submits it. The server executes sensitive tasks, sending back a response to the user agent. But the attacker, at some point, the attacker sent a phishing email to the user with a link to an attacker's website. The user clicks on it, and its user agent requests the HTML with JavaScript embedded page. When this is loaded in the user agent, instantly sends hard-coded form data to a sensitive endpoint on an honest server. As the domain is the same for which we stored a cookie, the browser automatically includes the session token in the cookies. The honest server executes sensitive tasks on behalf of the user due to the session token, and a response is sent back to the user. At this time, the browser notices the request origin is not in the course allowed origins and blocks the response to the user. But the malicious activity is already done. So how can we protect the flow against these attacks? Let's check the other sequence diagram. We have a similar situation, but now we have CSRF protection. The first difference occurs when any form is requested. In this moment, the honest server creates a random anti-CSRF token. This token is sent to the user agent, who stores it in the cookies. When the form sends back the data to execute some tasks, the form is sent with the previous token and the token is copied into the headers. Then the server compares the token in the cookies with the token in the headers to check if they match. If they do, then the process continues normally. But if any attacker makes the user click on a malicious link, this attacker's website can't know the token because it can't read the cookies. So when the attacker's website submits the form with hard-coded data, the server will notice that no proper anti-CSRF header was sent and will send back a not authorized error. Now we are going to watch this in action. I'm going to execute 3 projects and run them. One of them is an honest API in .NET, other is an honest app in Angular, and the third one is a malicious app in Angular 2. Let's check it out. Now we have 3 applications. One API that has 2 controllers, one of them called auth controller that allows a user to authenticate using a simple username and password, but this is just a fake method because the way it validates the credential is just checking that it is a hard-coded string admin and a hard-coded string password. If this matches, it is considered as an authenticated user. And in this situation, a cookie is append and a session in the server side. If you're authenticated and in the program CS file, when you enter to this endpoint, it is also created another cookie called XSRF-token with a CSRF token or XSRF token. This token is used by the Angular app to send them back in the headers. When it's sent back to the API in the header, we use a filter. We use a service, anti-forgery service, to check if it matches the header. And in this case, we can continue the requests. Another way, we will send back a bad request response. And the transaction controller checked it with this attribute validate anti-forgery token. And we have another method, create transaction vulnerable, which is exactly equal to create transaction, but with the difference that this method has other attribute that which is ignore anti-forgery token. And we have a list transaction endpoint which just display a list of transaction, just return a list of transaction. The list of transaction is just a list on memory, not database here for the example. And in the Angular app, we have the login page with a form with username and password, and the transaction page which display a list of transactions and a form which allows us to add a transaction with an amount and a destination account, which is just a string. And by the other hand, we have a malicious app. The malicious app has a fake email HTML, which is a page simulating an email. This could actually be an email in your inbox, in your Thunderbird, in your Outlook, in your Gmail, but in this case, for simplicity, we just add it in a HTML page. It's the same situation anyway. If you click on this link, as a user, you will be attacked. If you click on this link, the page will load this page, which is a form to the endpoint, create vulnerable with the fields, and by JavaScript, it will be auto submitted automatically. So it simulates a transaction to my malicious account with $1 million. We also have a secure endpoint, which is the same component as vulnerable endpoint, but with the difference that it calls to create instead of create vulnerable. So we call create, it's the same JavaScript. We call create, which is the other endpoint that is protected by anti-forgery. Create vulnerable is the endpoint that is not protected. So let's run this. We have here the main app. I log in. We can see that we have no cookies here. If I log, we have new cookies. We have the CSRF token, and I can add transactions to John and to Anna. Cool. But what happens when an email is received in my application or anywhere? What happens if I click on this link? This link will send us to the hell. Pop. Oh, what happened? What is this? What happened here is that the application made a, a call to the endpoint, to the create vulnerable endpoint. And if we refresh the original app, we have a new transaction made. It was made by the malicious application. Let's do it again. We can activate the network here and pop. We call vulnerable call, and after that we call create vulnerable with the data, the cookie, and the request. So we have now two new transactions. Okay, let's end with a call to the other endpoint. Secure call. What happens in this situation? If I call to the secure call, enter, bad request. We have a bad request response because this endpoint checks for the anti-forgery token and we have no header with the CSRF token. And this is, people, how CSRF protection works. I hope this video helps you to clarify this kind of security. If you have any comments or questions, don't hesitate on write them down on the comment section. Have a nice one. And don't forget to download the code that is in the link in the comments.